Hello, hello. My name is Darren Thomas, and I am the Director of Educational Research Technique. In this video, we're going to learn how to simplify complex rational expressions with division. So why don't we go ahead and get started? So as you can see here, we have our complex rational expression. And in case you forgot, a complex rational expression is when you have a rational expression as a numerator and or a rational expression as the denominator. And so you can see here that this is quite the messy problem here. We got here b over 1 minus 3b over b plus 5 over 2 over b plus 5 plus 1 over b minus 5. This is quite the mess. And now, for the A students, you're probably wondering, well, Darren, why do you have this b over 1? What's the point? Well, for those who are not as comfortable with solving these kind of problems, I don't want to leave out any of the steps. And so as I go through this, I will keep using this, having this one in the denominator for different purposes to go through the whole process of solving or simplifying this complex rational expression. Now, in order to have success with this is what you need to do. You need to deal with the top by itself. In other words, I'll explain in a second. You need to deal with the bottom by itself as well. And what do we need to do with the top and the bottom, the numerator and the denominator? Well, you need to find the LCD for the numerator, then find the LCD for the denominator, just separately. That's what we're trying to do right now. That's what we're trying to do. And then after that, we will deal with the division of the numerator and the denominator. But that's a separate step. So right now, we're just going to deal with this top guy right here. What do I have to do to make it so that this rational expression being subtracted from another rational expression, what do I have to do so that I can subtract them and try to simplify them? All right, so this is what we need to do. And also, again, we have to do this for the denominator as well. So here's what we're going to do. We are going to try to figure out what is the least common denominator, the LCD, for the top. And as I look at this, it's very, very clear. So go ahead and put a little equal sign here. We're going to have b. And now, for the least common denominator is going to be b plus 5. That's what it is. So, to make it simple, the least common denominator for b over 1 and 3b over b plus 5 is going to be 1 and b plus 5. That's it. Those are the two factors, that make up the least common denominator. That's what we're looking at here. So, having shared with you that information, this is what it's going to look like now. We're going to have b times b plus 5. Where did this come from? It came from right here. All right. I don't need to multiply by 1 because the 1 is already in the denominator here. That's why I put that 1 there, even though for the A students, you're probably thinking that was a waste of time. And so, of course, whatever I do to the denominator, I do to the numerator, I must do to the bottom, or vice versa. So now I have 1 times b plus 5. All right. Now minus, let's see here, 3b. And if I want to be true and follow all the steps, I will multiply this by 1, but we know that's redundant. But again, where did that 1 come from? Right here. I'm doing this because in other problems, the bottom number might not be a 1. It might be a 3, 4, 5, 6, 7, or whatever. And so I don't want to skip any steps for those who are new to this. Now, and then in the bottom, we have b plus 5. That was already there. And then we're going to, of course, multiply this by 1. Again, where did the 1 come from? It came right here from the denominator of this rational expression. But of course, we know when you multiply by 1, you get nothing. All right. Now, having done that, what's going to be happening here in our denominator of the whole complex rational expression? We're going to repeat this process. We already know that the LCD, just from prior experience of dealing with this, is going to be b plus 5 and b minus 1. Therefore, this is what we get. For the top, for the numerator, we get 2. That 2 is from right here. 2. And then we're going to have b minus 5 in the top. And then in the bottom, we're going to have b plus 5 and then b minus 5. Now, why are we doing b minus 5? B minus 5 came from over here. And so now I'm going to multiply the bottom and the top by this guy over here. I don't need to do the b plus 5 on the top because it was already here in the original rational expression. And now I repeat this process for the other rational expression right here, 1 over b minus 5. Now, I already have the b minus 5 here, so I'm going to multiply the bottom and the top by, if you can guess, b plus 5. So now I have 1, and then I have b plus 5. Excuse me, that's kind of sloppy. And then in the denominator, I have b plus 5, b minus 5. There we go. So that's what we have so far. Now, we can take the next step and try to simplify all this madness that we have so far. So essentially, this is what I have so far. I have so far. So right here, I'm going to deal with this guy up here, the numerator. Let me give you a slightly different color. So b times b is going to be b squared. B times 5 is going to be 5b, so plus 5b. All right. And then over here, 3b times 1 is going to be 3b. And then essentially all this is going to be over b plus 5. That's what we have here, because now we have the same denominator. That's what we're having here. And now all this over this nightmare right here. So we're doing this part right here. 2 times b is going to be 2b. 2 times negative 5 is going to be minus 10. And then that's going to be plus b, because 1 times b is b, plus 5. All that, I hope you can see this. And then we still have here at the bottom b plus 5, b minus 5. All right, let's move to another screen and get a little bit more space here. So this is what I have. This is continued from the last slide. I have b squared plus 5b minus 3b. Oops, excuse me, that's not an exponent. All this over b plus 5. And then in the denominator of my super rational expression here, I guess you can call it that, you got 2b minus 10 plus b plus 5, all this over b plus 5, b minus 5. That's what we have. Now, if I simplify this, it's a very, very simple process. I combine like terms. So, in the top, I have b squared. That's going to stay by itself because it has no other like term. So I got b squared. Oh my, this should be a b like that. Excuse me. Yeah, this is not an exponent. So and then I have plus 2b. That's what I have, plus 2b. All this over b plus 5. And then in the bottom, right here, let's see here, 2b plus, I got a b over here, so that's going to be 3b. 3b minus 5. And then I know it's hard to see this. I'm going to put it right here. Then I have b plus 5, b minus 5. So all I did was combine like terms. So I'm dealing with the top, and then I'm dealing with the bottom. I'm dealing with the numerator, then I'm dealing with the denominator. That's what I'm doing, back and forth like that. Dealing with the top, dealing with the bottom. And so let me write this on another screen for you, make it nice and clear. This is what I have now. I have b squared plus 2b, all this, over b plus 5, and then underneath that, my really, really big guy here, then we've got 3b minus 5 over b plus 5, b minus 5. So we're getting very close to being done here. Now, as you know that when you have to divide rational expressions, you take the second rational expression, the one to the right of the division sign, and you flip it. You get the reciprocal, and then you can multiply across. So what we really have here is the following. We have b squared plus 2b over b plus 5. Okay, that's a plus. Now I'm going to flip this second one. So I put the multiplication sign, and then now it's on the top, I have b plus 5, b minus 5, like so. All that over 3b minus 5. That's what I have. And so we're getting very, very close to being done here. Now, let's move to the next slide because we're running out of space again. So here we go. We're almost done. This is the problem that we're working with right now. We got b squared plus 2b, all this over b plus 5. All right. And then, of course, we're doing multiplication, so we can just draw the line and just keep going, basically. And but let me do this. I'll put the multiplication sign, and then we got b plus 5, b minus 5, like so. All this over 3b minus 5. All right, now, here's what we're going to do. We're going to factor out this b squared plus 2b to make it simpler. And this is what we're going to get when we're getting very close to completing this problem. So now I have a b outside like this, and then I have a b plus 2. That is the kind of the factorization of this guy right here. Then I have the b plus 5, the b minus 5, and then on the bottom, like so, I have a b plus 5 again, in parentheses like this, and then I have a 3b minus 5, like so. That's what I get. So now what do is we remove like pairs. There's not a lot of them, but there is some. So I got a b plus 5 here, that can go away. I got a b plus 5 here, that can go away. And we're getting very, very close to being done. So if I had to simplify this as much as possible, this is kind of the final answer. I would have b plus 2, b minus 5, all this over 3b minus 5. And we're done. That was a lot of work. But again, basically what you're doing here is that you're taking two rational expressions here that are kind of happening at the same time, and you're trying to simplify them almost like simultaneously. You're dealing with the numerator, trying to find the least common denominator for that. Then you're dealing with the denominator, finding the least common denominator for that, and then working your way through. When you finally have simplified the numerator and the denominator all the way through, that is when you finally deal with the actual division or the multiplication when you switch them. But after working through all that, you get this final answer right here, which was a lot of work. So let me see if I can kind of walk you through this again. We started with this messy problem here, and I already kind of talked about how to deal with it. B over 1 minus 3b over b plus 5, all this over 2 over b plus 5 plus 1 over b minus 5. And so like I just said a few moments ago, the first thing you do is that you find the least common denominator for the numerator, and then you find the least common denominator for the denominator. And so after you do that, you can start working your way through simplifying the problem. It's not that difficult, because once the numerator has the same denominator, you just combine like terms. That's all you do after you deal with any kind of multiplication that might be necessary. And you repeat this process for the denominator. All right, and so you can see how we're working through it here. Again, we already talked about all this. Simplifying things, combining like terms. And then when you have all the terms simplified, then it's time to deal with the actual division of the actual the mother complex expression, if you will, or the complex rational expression, excuse me. And so again, when you're dealing with division of complex or with rational expressions, remember that you multiply, but you use the reciprocal of the term to the right of the division sign. So here we have our division. So this will be like our first number here to the left, and this is the one to the right, if you will. If I wrote the division sign using this form of notation, this division sign notation. And so down here, we flipped it. So this used to be right here, b plus 5, b minus 5 used to be the denominator. But since we have to do division, we flip it and put it on top as a numerator, and the 3b minus 5 became the denominator. And so then from there, it's just a matter of working throughout the multiplication right here, and you get your final answer as shown. When you get close, you remove like terms, and then you're essentially done here, right here at this step. And so I hope this was a lot of work, but again, this is a very valuable tool as you move into more complex forms of mathematics. I hope that this was clear for you and that you're able to apply this when you have to do your homework or deal with any kind of assignments involving math. My name is Darren Thomas. I am the Director of Educational Research Techniques. Take care.